dear pupils. I hope you're fine. With you again this day is Mr. Walter, your science teacher, ready to take you through a science lesson. I'd like us to briefly remind ourselves on what we discussed in the previous lesson. If you remember, we discussed about the types of mirrors, which we said we have three types of mirrors: the plane mirror, convex mirror, and the concave mirror. We looked at how reflection takes place on plane mirrors, and we ended up having a diagram which has the parts as shown in this diagram here. Can we briefly remind ourselves the parts of this diagram? This is a ray that comes from the source, and we say the ray that comes from the source is known as the incident ray. The incident ray. 2. After the ray has struck on this plane mirror, we say it is reflected. So this is the ray that is reflected, or it bounces off the smooth surface, whereby here we are using a plane mirror as the smooth surface. So this ray that bounces off, we call it a reflected ray. It's called a reflected ray. Between the incident ray and the reflected ray, we have another ray that is shown by the broken lines. And this ray that is between the reflected ray and the incident ray is called a normal ray. Alright. Between the normal ray and the two rays, that is the incident ray and the reflected ray, we have angles that are formed. We have angles that are formed. The angle that is between the incident ray and the normal ray is known as the angle of incidence. That is known as the angle of incidence. The angle between the incident ray and the normal ray. Secondly, we have another ray that is between the reflected ray and the normal ray. That ray is known as the angle of reflection. It is known as the angle of reflection. Then the surface whereby reflection takes place is our plane mirror. So these are the parts that show us the reflection on a plane mirror. Now, I want you to look carefully on these two types of rays. That is, the ray from the source to the plane mirror is shown by an arrow moving towards the plane mirror, and the one that is reflected has an arrow that shows a direction away from the mirror. Some pupils now, sometimes they might confuse. Look at my diagram 2 and look at the arrows where they are pointing at. In diagram 1, this ray that was on this side has an arrow pointing towards the plane mirror, and this one away from the mirror. mirror. But if you come to this is our plane mirror. Look at the arrows. The one that points towards the plane mirror is the one that is known as the one known as the incident ray. So therefore, in this case, this one here is our incident ray. This is the incident ray. So for you to know, you have to look at the arrows. The arrow that points towards the plane mirror, it means it's a ray coming from the source. So therefore, that is our incident ray. And this one here, you see very clearly, it is pointing away. It is bouncing off the plane mirror. So this one here is our reflected ray. So meaning that it does not really mean that this side has to be incident ray and this side must be the no. We have to look at the arrows. The arrows are the ones which direct us on which is an incident ray and which one is a reflected ray. Now, when we talk about the law of reflection, we are going to look at the angles. The law of reflection says clearly that the angle of incidence is equal to the angle of reflection. The angle of incidence is equal to the angle of reflection. Here we have our diagrams that show the parts of reflection. Now, this part is called our angle of incidence. If this angle of incidence is 48 degrees, and then somebody is going to ask you what is the size of angle E. Angle E, this one being our angle of reflection and this being our angle of incidence. What have we understood about the law of reflection? We have said that the angle of incidence is equal to the angle of reflection. So therefore, if this is 48 degrees, then this angle E will also be 48 degrees. They are the same. We come down here. Let's assume this is angle 50 degrees. That angle has the size of 50 degrees. Then somebody asks you what is angle A. I'll ask, which angle is this? Some of you will tell me this angle of incidence. No, this is the angle of reflection. Look at the arrows. This is our incident ray, so therefore this angle is our angle of incidence and this is the angle of reflection. So, if this is 50 degrees, what will be the size of angle A? Angle A is also going to be 50 degrees. What about this one here? We have it here, that is 43 degrees, and then we want angle C. This angle of incidence is 43 degrees. The law says the angle of incidence is the same as the angle of reflection. So therefore, if this is 43 degrees, then angle C is going to be also 43 degrees. I believe you have understood that. Now, you can get some different questions whereby now they have not given you that angle of incidence, but they would like you to get one of them. Look at this diagram and then we shall see what we are supposed to do. Now, we assume that they have given you this angle that is outside here. This angle is 56 degrees. And then they want you to find this angle here, the angle of incidence. What are we supposed to do? Class, my dear pupils, what we need to do here is, first of all, we must get that angle there. And how do we get it? Remember that in the previous lesson, we said the normal ray strikes on the surface of this at a right angle. When we say right angle, it strikes there at 90 degrees. So therefore, how do I get that one there? Remember, that is the normal ray that we have, and this is that line that shows the plane mirror. Then this one is divided into that. We say this is 90 degrees, isn't it? But there is this 56 degrees which has been minus from 90 degrees. So therefore, how do we get this angle here? We have to get 90 degrees minus 56 degrees, which is going to give me 34 degrees. So therefore, this angle here is 34 degrees. So they want angle Y. We go back to our law of reflection. We say the angle of incidence is equal to the angle of reflection. So this one being our angle of reflection and Y being our angle of incidence, so therefore angle Y is also equal to 34 degrees. That one can be done also even if we assume that now they have given us on this side, that is 42 degrees. They want this angle here, angle P. You use the same method. It means for you to get this, you must get that angle there, that angle of reflection. How do you get it? 90 minus 42, which is going to give you 48 degrees, meaning that this angle of reflection is 48 degrees, and this, if it is 48 degrees, then what will be angle P? I believe now you understand what I mean, that angle P will also be the same as 48 degrees. Thank you very much for today. I hope you have understood on how to get the angle of reflection and the angle of incidence. Thank you very much for today. May God bless you. Till next time, please stay safe.